Hello dear students, I am Pratima. I welcome you all to this video. So today we are continuing your real numbers exercise 1.3. But to solve these questions, we need to know some theorem so that we can proceed. So this theorem is, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. What does it mean? If square of a positive number A square is divisible by P, P is a prime number, then A is also divisible by P. Let us take the example, then you will understand better. Suppose I take number 4, its square is 16. 16 is divisible by prime number 2. So 4 is also divisible by 2. Where we'll use this to prove a number to be an irrational number or rational number. But most of the questions are to prove irrational number, so we have to keep in mind this logic will apply. So first is to prove that root 2 is an irrational number. So this is will prove logically. So try to follow the steps, right? Try to note down the steps. This will prove by contradiction method. Contradiction. What is it? Contradiction means first we are assume that let it is a rational number. Then we'll find that it will not satisfy all the properties of the rational number. So then we'll conclude that it is not a rational, it is a irrational. So what will be my answer? First answer I'll start that let root 2 be a rational number. I am assuming. So when it is a rational number, it can be written as P by Q form, where P and Q are 4 prime and Q is not equal to 0. You know the definition of rational number. Now what we'll do, I'll square both the side. Squaring. Squaring both the side. What I'll get? I'll get square root of 2 is 2. Here it will be P square by Q square. Or I can write P square is equal to twice Q square. Cross multiplication. So I am getting a condition now. P square is divisible by 2 because it is multiple of 2. P square is divisible by 2 because it is 2 into something, so it is divisible by 2. This implies that P is divisible by 2. When P is divisible by 2, P has factor 2. This is relation 1. Now when P has a factor 2, P can be written as twice R. It is let P is equal to twice R. Then now again squaring, I'll get P square is equal to 4R square. Now P square is equal to 4R square, I'll place here. Then what I'll get? Or I'll get 4R square is equal to twice Q square. Or twice q square is equal to 4r square, or q square is equal to 2r square. What does it mean? It means that q square is divisible by 2. When q square is divisible by 2, q is divisible by 2, or q has factor 2. So p has factor 2, q has also factor 2. So this contradicts that they are co-prime because they have a common factor. So it contradicts that p and q are co-prime. That means our assumption was not correct. That means root 2 is not a rational number. So root 2 is an irrational number. Next, exercise question: prove that root 5 is a irrational number. In the same way, we will proceed. Let root 5 be a rational number. So it can be written as root 5 is equal to p by q, where p and q are co-prime and q is not equal to 0. Next is squaring. I'll get 5 is equal to p square by q square, or p square is equal to 5q square. P square is divisible by 5. This means p is divisible by 5. If p is divisible by 5, then let p is equal to 5 into r, or p square is equal to 5 r 25 r square. Now replacing p square with 25 r square in this expression, I'll get 25 r square is equal to 5q square, or q square is equal to 5r square. Then this implies that q square is divisible by 5. When q square is divisible by 5, this implies that q is divisible by 5. When q is divisible by 5, p is also divisible by 5. That means this contradicts that p and q are co-prime. So our assumption was not correct. What were our assumption? That it was a rational number. So root 5 is not a rational number. Root 5 is an irrational number. Similarly, question number 2, prove that root 3 plus 2 root 5 is a irrational. So since there are two number, one is rational part, one is irrational part, we have to write in different way. So how to write? Let 3 plus 2 root 5 is your rational. Then 3 plus 2 root 5 can be written as p by q, where p and q are co-prime and q is not equal to 0. Then I'll write p by q is equal to 3 plus 2 root 5, or p by q minus 3 is 2 root 5. I shifted 3 to left side. So what does it gives you on simplification? P minus 3q by p is equal to 2 root 5. Of course this is q, this is not p. By mistake I wrote p. It will be q. Okay. Or I'll write p minus 3q. 2 I'll take to denominator is equal to root 5. Here we will find the contradiction. What is it? P, Q are integers. So P minus 3Q by 2Q is rational. That means LHS is a rational number. But we know already, we have proved root 5 is irrational. So when it is irrational, we reach at contradiction. So our assumption was not correct. That means 3 plus 2 root 5 is not rational number. 3 plus 2 root 5 is irrational number. Question number 3, prove that the following irrationals. I hope you can write yourself in that way. If you can't write, so I'm giving some hint, but pause the video and try to write down yourself. For part 1, let 1 by root 2 be rational number. Then 1 by root 2 is equal to p by q, and you have to mention p and q are all integers and co-prime. That means they don't have common factors. Q is not equal to 0. Then what is there? P is equal to p by q is equal to 1 by root 2, or root 2p is equal to q, or your q by p is equal to root 2. Q is integer, p is all are integers. So q by p is rational, but we know that but under root 2 is irrational, because we have already proved it. This is a irrational. So I explain again, p by q is 1 by root 2. So I cross multiplied, q is equal to root 2p. So we'll keep only this under root portion side one side. You take others to one side. So q by p is equal to root 2. This is rational, this is irrational. So this is the contradiction. We reach at contradiction. We are equal, you are making equal rational with irrational. We reach at contradiction. So our assumption was not correct. That means 1 by root 2 is not rational number. 1 by root 2 is irrational number. Second part, 7 root 5. 7 root 5. Let 7 root 5 be a rational number. Then it can be written in form 7 root 5 is equal to a p by q, where p and q are co-prime. Q is not equal to 0. Then I'll write what? P by q is equal to 7 root 5, or p by 7q is equal to root 5. So here you will write left hand side. You will write that left hand side is a rational number because p is an integer, q is an integer. So p by 7q is rational. But root 5 is not rational. So we are making some contradictory things. Left side rational, right side irrational, and making them equal. So our assumption was not correct. What does it mean? It means that 7 root 5 is not a rational number. Seven root 5 is an irrational number. Third part, 6 plus root 2. Let 6 plus root 2 is a rational number. Then 6 plus root 2 is equal to your p by q, where p and q are co-prime. They are integers, and q is not equal to 0. Then p by q is equal to 6 plus root 2, or p by q minus 6 is equal to root 2, or p minus 6q by q is equal to root 2. Write the same logic, but set p minus 6q by p is rational, but root 2 is irrational. So we reach at contradiction. That means 6 plus root 2 is not a rational number. 6 plus root 2 is an irrational number. Thank you for watching. Thank you for subscribing.